Hello everybody, Root Beer here with question number 18 on the 2003 Fermat paper. A car uses 8.3 liters of gas for every 100 kilometers it's driven. A mechanic is able to modify the car's engine at a cost of $400 so that it will only use 6.3 liters of gas per 100 kilometers. The owner determines the minimum distance that she would have to drive in order to recover the cost of the modifications. So how far does she have to drive to the point where if she hadn't modified the car, she would have been $400 more than the cost of gas with the modification, I guess is what they're saying. Yeah. So if the gas costs 80 cents per liter, this distance in kilometers is between, okay, we have a range here. So I'm suspecting that since we're given a range, we might need to grab our trusty calculator, because there might be an expression we just need to calculate, and it'll fall into one of these ranges here. Okay. So, in order to answer this question, we need to set up two equations. We'll say D is the distance that she drives. D is the distance that we're trying to work out. Okay? That way, when we solve our equation, then we get our D, then we can, if we need to, plug it into a calculator or otherwise locate it in these sort of buckets. Is it an A? Is it B? That sort of thing. So that will be our distance, and what we need to do is perform two calculations or get two expressions. One expression is how much gas, or how much money she would have had to spend on gas to drive that distance D, if she hadn't modified the car. The other calculation we need to do is she's paid $400 for the modification plus the amount of money she needed to spend on gas to go that distance with the 6.3 liter modification. And we'll get two equations, and hopefully out of there we'll be able to figure out what D is. Okay? So, let's get to it. 8.4 liters, 6.3 liters, and 0.8 liters is the cost of gas. So gas is $0.8 per liter. 8.4 liters per 100 kilometers is her old. Is that mileage? I don't know enough about cars. Well, I guess, would it be mileage even though we're in metric? I don't know. So I've written down the appropriate numbers. So I'm going to say let D be the distance. She needs to drive to break even. Okay. So, breaking even means if we calculate the cost one way and calculate the cost the other way, they need to be equal. Okay? And then after that point, the 6.3 liter per 100 kilometer modification will be saving her money. Okay? So that's something we need to keep in mind. So, if she had just kept with the, we'll use red for it, not modifying her car, so her less fuel-efficient engine, she would have had, how much would it have cost? So it'd be D kilometers. So we need to find a way to cancel out those kilometers and turn it into money. So D kilometers times 8.4 liters per 100 kilometers. So now the kilometers will cancel out. We'll be left with liters. I don't want liters, I want dollars. So what thing gets rid of liters? The gas divides by liters, and we're left with dollars. Okay. So we set up this equation, and we know it's right because the units are going to cancel out. Okay, and we'll just be left with dollars. So we'll have 0.8 times 8.4 divided by 100 times D. And I suppose we can clean that up a bit. If I had 8.4 divided by 100, I'd get 0.084 times 0.8 So we're looking at 0.0672 D. Okay. Where D is a number, not a number with kilometers, because we have kilometers and it's already been canceled out over here. So that's how much it would have cost to drive distance D kilometers if she hadn't modified her engine. Okay. Now, if she did modify her engine, she's already paid $400, and we'll use blue here, I guess. So she's already paid $400 to the mechanic to make the modification. And then we add on the cost of the gas. Gas cost 0.8 per liter, and she did 6.3 liters per 100 kilometers for D kilometers. Okay. So this is, once again, the units are going to all cancel out. And we're going to be left with $400 plus, and now 0.8 times 6.3 is 5.04 divided by 100. So plus 0.0504 D dollars. I want these two expressions to be equal because she is breaking even. So I set them equal. And at this point, it is just a linear equation. So we bring all the D's over to one side. We can factor out the D, and that's equal to $400. We can drop the units. And so now D is 400 divided by this difference, 0.672 minus 0.0504. And that is 0.0672, just grabbing my calculator, 0.0504. 400 divided by 0.016. And so I'm getting 23,809. And I think that was sort of in our range. Is that in one of our ranges here? Yes, it would be in range D, because it starts with 23. So our answer here is D. Okay, an interesting little question. And we can go on to question number 19, but we'll have to wait for that in the next video. So as always, thank you guys for watching, and I'll see you for question 19 on the 2003 Fermat in the very next video. Okay, so long for now.